Thanks to Squarespace for sponsoring this video. If you need a website, go to squarespace.com/JamesBruton for 10% off. This is part 2 of messing around with pneumatic actuators and trying to make a useful robotics actuator that I can position proportionally. But first of all, I have to say that OpenDog is still an ongoing project. I've said this in a few videos. It's right here. I'm using it as a table, and that's because basically the next stage of that project is to upgrade all the electronics, do some hardware upgrades, but also fundamentally rewrite the software so that I can do what I want to, or at least restructure it, and then actually make it walk properly. So that's quite a lot of work, and I can't do a video on it every week or every 2 weeks because there won't be anything significant to put in that video, so I really want to provide updates that are worthwhile, but that is definitely an ongoing project. So last time we got this pneumatic actuator. This is left over from the Transformers build where we built Bumblebee that turned from a car into a life-size transformer. Check that out in my channel. That was a pretty big build, and we needed some high power actuators, but we didn't need to position them too precisely. We just basically ran them to their end stops, and that was about it. And we had 4 cylinders like this. There's 2 longer ones in the legs. So that build's finished with, and I thought it'd be good to try and use these actuators for another project, perhaps another giant walking robot project. But we probably need some more accurate positioning. So the idea was to try and build a system that could proportionally position these like we can with electric actuators, but obviously we get much more power for the cost. So we've got this rig with a feedback pot. Obviously this is temporary for testing. A bit of string and a spring probably isn't going to be much good in a giant robot. And I'm aware you can buy cylinders with positioning and position feedback built in. In fact, you can buy the whole system, but there's no fun if you don't make it, and that's what we're really trying to do. There's also some comments about the valves that I'm using, which were 3-way valves, so check out the last video on this. You can get a 5-way 3-position valve that would lock air into the cylinder, which is far more ideal. But I don't have any of those, and I've got loads of 3-ways. And this arrangement lets us see where the air is flowing much more easily, because we've separated out each side of the cylinder. So if I was going to build this into another project, we probably would use different parts, or at least some different parts. But for the purposes of testing, we're going to use what I've got available. So last time we fundamentally had this working. You can turn the knob and it matches that with the feedback pot position and turns on and off the valves accordingly. So these are only on and off valves, and what we did was held them both on. That held air in both sides of the cylinder, and then we turned one off, which of course allowed the cylinder to move in that direction. And what we did was we actually restricted the output with G-clamps on these hoses, which was pretty crude, but that meant air could only go out slower than it could come in, so we always maintained pressure in the cylinder. So the first problem we found last time was we're using a single air source to feed both valves, just with a T-piece on the input here, and due to this bar, which is part of the cylinder, poking in one side of the cylinder, we've got less volume here, and therefore less surface area pushing on the stopper that pushes it up and down. So the back end of the cylinder's actually got more force available because it's got a bigger surface area, and that meant that basically when we tried to hold this with pressure in both sides, the cylinder tended to want to go this way, and it pushed air out of this side, back through the valves, through the T-piece, and into here, and that meant that the cylinder crept. We couldn't hold it in position. So ideally we'd have a valve we could actually lock the air in, and that would solve it, but I've actually already ordered some non-return valves, so I'm going to stick those on first and try with a single air source. And they look like this, which is basically a check valve or a non-return valve, which is just a one-way air valve basically. The other issue of course was when we tried to backdrive the cylinder, it pushed air all the way back through and back into the air reservoir, and of course that will stop this as well, so it should hold much more rigid. So last time we isolated the air sources for each side of the cylinder to stop that creep, so we had this tank and the compressor. So now I've got rid of this tank and we're just using the compressor linked straight to a T-piece, and we've got the 2 check valves installed so that we hope that air doesn't come back down here and into the other side of the cylinder. I've also got my G-clamps installed, which of course are temporary. It's just a test, guys, so that we can restrict the output flow there and we don't just completely depressurize one side of the cylinder when we open the valves. However, we've still got a problem, so I can activate these valves manually for now just by pressing the buttons, and before what I did to hold it in position was activate both of them. But what you'll find is, in fact, there is some creep still, which isn't very good. It's only very slight, and it does actually move that and it won't hold it in position, whereas last time with the 2 air sources completely isolated it worked really well. So it must be, of course, there is more pressure on here, more surface area pushing this cylinder, there must be some return back through the non-return valves. They must be non-ideal, and that may be because there's still pressure pushing this way and it's holding them open or something like that as well. So there is a tendency for air to go back. So ideally we'd use a different type of valve, as I said before, which would, when the valve is off, would lock air in both sides of the cylinder. When I turn these off, it vents both sides of the cylinder. So you'll have to bear with me on this one. This is an R&D video. I thought it's interesting to show me doing the development, because I need to do it anyway, so it might as well be a couple of videos. Otherwise I'll go on to build a giant robot and it won't work properly. And normally things I build work first time because I do the testing. So as I say, we could get a valve which has like that 3 position, so it's off in the middle, locking the air in, then it switches either way and that lets air out of one side and pushes it in the other side. And that's actually designed for controlling a cylinder like this. So we don't have one of those, so I could go back to 2 separate air sources. When I isolated those, of course, there was no way air could go back into the other side of the cylinder, so it held it fairly rigid. The problem with that is that basically we could have different air pressures in those cylinders as we move it up and down and vent them. One will become higher pressure, or at least one will become lower pressure than the other, so that's not ideal as well. So I could scrap this video and go and order a valve, which will take a while to arrive and the video won't be done in time, but actually it might not be a problem, because the next thing I was going to do was try and build a proportional valve to replace those G-clamps. And yes, I'm aware you can buy them, but I'm actually going to try and build one with a servo and some plumbing accessories. And of course that will actually lock off the air completely, so we could use that in fact to adapt this system to lock both sides of the cylinder with air in instead of venting them by closing the output. So we've got some plumbing accessories, including one of these isolation valves, which has got an arrow which normally would carry water through, and it's got one of these quarter turn things for a screwdriver. So hopefully you can just see in there, there's a sort of ball arrangement that opens, which could be quite proportional if you open it a little bit, so I think that's going to work quite well. And this is a compression fitting for 15mm copper pipe. So I've also got a compression fitting that takes a 1/4 inch BSP, so I can go to my barb. Yes, I'm aware there's better pneumatic fittings. And what we're going to do is only make one of these, so we're going to use a T-piece, which will take the hoses from those 2 G-clamps on the pressure release of both solenoids. So we only need to build one of these, so I'm going to put all this together with some pipe and mount it up, and then basically try turning this manually to start with, and if it works well, we'll make it servo controlled. Right, so that's now mounted up. We've just got it on some 3D printed blocks to hold it down so we can screw it down later and put a servo on there. So I'll turn this with a screwdriver, which lets pressure out of the cylinders, and let's just manually activate moving in this direction. Obviously nothing happens till we let air out of the other side. So now if I turn them both off, we still get the creep. And that's because now these solenoids are both off. Both the releases are connected through this T-piece, which is connected to here. So now air can still go back through the T-piece and back into the other side, into the higher volume side. So obviously if we did have the proper valve, when they're both off, it actually locked air in, that wouldn't be a problem, but we haven't. So what we're going to need is 2 of these, so we can still isolate the cylinders. Alright, so now I've got 2 of these, and they're both linked to the 2 releases, so they're not on a T-piece anymore. One lets air out of one side of the cylinder, and one lets air out of the other side of the cylinder. So when I put air into one side and let it out the other side proportionally with this little valve, we should be able to move it. When these are closed and these are closed, air should be locked in the cylinders, and it should hold solid. So let's see what happens. So first of all, I'm going to operate this one. And which side? This side. So we're going to move the cylinder that way, and then shut it. That seems to work all right. And then let's go back the other way. So that's full pressure now. So let's open that and shut it and let go of both, and it should hold it. There's a little bit of creep. It may be because I've got quite a long hose here and the air is compressing, still pushed by the higher volume on this side. It's a tiny amount of creep. We didn't have that last time. Let's just go back the other way again. So I should be able to do a nice deceleration curve there and then hold it. There's a little bit of creep. But if we were to measure this position and build a proportional system, we could probably make it so it holds it, or at least tries to correct it. Yeah, that's a little bit weird. I mean, ultimately there's more force on this side pushing it, so it's going to compress the air more, I suppose. But there we go. When we isolated the air sources last time, it didn't do this, but then we did have both sides holding pressure, pushing, instead of them being off and locked. So I guess that might have balanced up the amount of pressure or something like that. Right. So that goes that way. And if I shut them, yeah, I mean, it basically works. It's just a tiny amount of creep. We'll have to think some more about that. So now I've just shut all the valves, but I've put as much air in as I can by pressurising both sides of the cylinder, shutting the exhausts until this thing basically holds solid, and now we can see how much force we can hold. So I'm going to try and push and pull this by hand, and I think I can move it a little bit, and there's a little bit of the air compressing back to these, but pretty much that's solid now, and I can't keep pulling it in that direction of creep. So I think once initially the force on this side has compressed the air in this side, then it will hold solid. So that means we can probably fix it in code. So it's the next day and I've slept on it and thought about it quite a bit, and before I try and fix that in code, I've decided to try again with 2 air sources because that worked really well last time. So now what I've got is the original compressor and this other tank which we had in the last video, and basically they're both connected directly together to charge them, so they have to be the same pressure. There's no way, there's no regulator in between, nothing like that, so they must be identical pressures to start with. Those are then both connected, one each, to the 2 pressure inputs of the valves that go to each side of the cylinder. The T-piece is on the release, that's the vent basically, and that goes out to my one single flow restrictor. I've still got the check valves in here, but last time we didn't have those, but I'm leaving them there because they're fixed on pretty well. And then we've got our single flow restrictor that's connected to that T-piece, so that's only connected to the valves when the valves are off, but what we're going to do is, as we did last time, hold both valves on to hold position and only let one off at a time, at which point only one half of the cylinder is connected to this at a time, so we never have that situation where air can go from one side of the cylinder to the other through the T-piece. So now we hold both of these on to hold position, which seems to work pretty well, and then we let one off to move it. So if I want to move it to my left, I can do that, and you'll notice there's a bit of creep there, but if I move it the other way, it does creep in the opposite direction. So I think that's quite normal just with the air compressing. So I move to the left and it holds it doesn't creep anymore. And that's the other way. Obviously it creeps a little bit in the opposite direction, but then it holds it and it doesn't creep towards the lower pressure end anymore, or the lower volume end I should say. So this is what we had last time, and I wanted to check that I wasn't crazy, but that does seem to be working pretty well. So there's a tiny bit when you finish, just moving in the opposite direction, but then it holds it solid. So yeah. And obviously we've got our single pressure thing here. We can now put a servo on and make that proportional. So why does it work with 2 air sources and there's hardly any creep there? It's much better than it was when we did the other things, which included locking air in the cylinder, the check valves. Obviously if we did have a 5-position 3-way valve, that wouldn't appear to help us, because locking air in the cylinder, which I did kind of manually with the 2 release valves and the 2 solenoid valves, still meant we got that creep for quite a long time after we moved the cylinder. So the only answer I can come up with is that when we lock air in the cylinder, we've got one higher volume side and one lower volume side due to the stick that's part of the cylinder, and so that's quite a big difference, which is pushing the cylinder, of course, in that direction. But when we tail off 2 24-litre air tanks, obviously the difference is the 24 litres plus the volume here, or the 24 litres plus the slightly smaller volume here. So compared to that whole massive volume, the difference is actually quite negligible between the 2 volumes. So we've got 24 litres plus a bit and 24 litres plus a very slightly smaller bit, so that's hardly any difference. So perhaps that's why, in fact, it's much more forgiving, and the natural friction of the cylinder just takes out any difference there would be, and that's why it's much better at holding its position. Of course, people are going to shout at the screen and say it's not the volume that pushes a cylinder, it's the surface area on the stopper in the middle, which of course is still identical, but I can't come up with a better answer. So if you think you know better, given those experiments, then make sure you've watched all the video and all the experiments I did, and put those answers in the comments. So for now I only have to make one proportional valve on my output so that we can do nice deceleration curves, and that's actually what I intended to do in that video, even though we're 11 or 12 minutes in. But anyway, I'm going to do it now and see if we can make a nice deceleration curve. So I've now added a lever on here with a bit of aluminium. I've just filed a little notch to fit in where you put the screwdriver. We've got a 3D printed mount so this thing can swivel. We don't need to move it very much. Putting it completely this way will be full open, but that's far too much air let out. So we only need to move it about that much. So I'm just going to use this servo. It's a 20 kilogram digital servo. So basically moving that whole servo about 90 degrees should hopefully move that enough that we can let air out enough, and then we can close it and open it as we wish to control the speed of the cylinder, or we can of course shut it down as we come to our position, make it proportional so we can do nice deceleration curves. So now we can control that valve electronically with this servo that's attached. So we can open and close it with the servo, which is attached to the control Arduino that controls everything. That means we can control the speed at which air exits. We can also try and do a deceleration curve. So as the difference between the demands pot and the feedback pot gets smaller, we can close that valve and decelerate so we don't overshoot, or that's the plan anyway. So if I turn this knob now, you'll notice as the error gets bigger, one of my solenoids went click there because the cylinder's moving in one direction. It opens the valve up. As we get back to the position where the two pots are the same, it closes the valve again, and the other way it opens it again. So that gives us some quite interesting results. And of course what we are doing is when we're closing this valve, we are actually restricting the flow completely, which causes some unexpected results. So now we should be able to proportionally control the cylinder. So if I turn this way, you can see the valve opening, and we've still got a little bit of creep there, but we should be able to see this when the error is bigger, opening a lot, and then clamping it down slowly to hit this without overshooting, or that's the plan anyway. So that worked quite well. And that worked quite well. Oh. Right, now the Arduino's actually hung, and that's because the back EMF off these solenoid coils is quite high when there's air in them. So sometimes if they switch too quick, it kills the Arduino. So I've got ferrite cores everywhere and suppression capacitors, but apparently that's not enough, so I'm just going to reset that. When it works, it works. Sometimes. Nope, it's hung again. This really isn't very reliable. Let's just try this way. So I think what's happening is, when we're moving in this direction, we've actually got some of that creep back, and I think that's because we're shutting this and shutting the other half of the valve, which is locking air in the cylinder, and when we did that, it caused creep. So yeah, that causes it to jitter, the valve switch really quick, and the back EMF kills the Arduino. So moving that way is much better. No, it's all hung again. Right. Good, there's a big proportional move, that worked. So moving one way is definitely better than the other way. Although it does work, but then it jitters. So yeah, pretty sure that's because we've locked air in the cylinder, and that's when it didn't work. So perhaps we could use this for speed control, but if we try to lock it down to nothing to stop the cylinder gracefully, then we get a bunch of issues again. So I guess the lessons learned from doing all of this, and it is an R&D video, I'm aware you can just buy a proportional system, but you don't learn anything unless you make it yourself and work out what's going on. Obviously if I'd just done it the way I thought it should have been done, I'd have had that sort of 5-way 3-position valve instead, and it never would have worked in the first place. So by doing it this way, I've discovered that if you separate the valves, and you leave them both open, and you've got 2 separate air sources with massive reservoirs attached, then the creep goes away, which doesn't make any sense. And if you think you know why it's doing that, then of course put the answers in the comments there. When we start to lock air in the cylinder, as you would with a 5-way 3-position valve, then of course you get the creep again, which is a bit weird. So I think this servo thing, obviously it's very hacky, it's DIY, I could buy a proportional valve, but we could use that for electronic speed control by restricting the airflow going out. We could go proportional valves on the input. I'm not sure what the result would be there, or whether that would cause a whole bunch of other issues that we can't predict until we try it, so I'm not actually going to do that. I think if I was going to go and build a giant robot using these, I probably wouldn't rely on proportional control, at least not a DIY solution. I'd probably just rely on pushing it right to the end and have a hard end stop like we did in Transformers, which is how people normally use pneumatics. And the other solution, of course, would be to have the position control we had, and there's nothing wrong with having 2 air sources, 2 compressors with 2 regulators, so we always get identical pressures on each one. Could work quite well if we do need that sort of granular position control, but probably not proportional. So I hope you've enjoyed the R&D, that's the purpose of this video. Thanks for all the comments, and don't forget to subscribe. Thanks again to Squarespace for sponsoring this video. Squarespace can provide websites, domains and online shops. Don't forget to use the link in the description to this video to get 10% off. That's squarespace.com/James Bruton. Alright, that's all for now.